All right, kids, let's see here. We're going to review questions 3, 4, and 5. Let's go ahead. You know what? Holy. All right. Atterbury is ready to go. So you should have a calculator ready to go. Okay, the calculator should be at least, as they call a scientific calculator. You'll notice that it's got a lot of these extra features and functions. Okay, particularly we're looking for the sine, cosine, tangent, and also, okay, if you zoom in, you'll see it's got the inverse sine, inverse cosine, inverse tangent functions, which are written above sine, cosine, tangent. It says the sine to the -1 power, cosine -1 power, tangent -1 power. Okay, those are the inverse functions. You will need those. Okay. So if in a right triangle, theta is 17 degrees and the side opposite to theta has length 8, how long is the hypotenuse? Round to at least 3 decimal places. All right, so this is what they want you to do. Okay, so this is question 3 from your problems. Okay, and that isn't really okay. So question 3 is going to look like this. You've got some right triangle. Okay, you can draw any type of right triangle you want. I think last class meeting we drew a lot that looked like this. So, or the other way. It honestly, as long as you draw everything out as they say, you'll be fine. But there's no one exact way to do it. But they should all work out the same. So in a right triangle, let's just call that our angle theta. Okay, it's a right triangle. It's a right angle. It's 90 degrees. This is going to be 17 degrees. We don't know this angle yet. We can solve for it, no problem. But the side opposite to theta, which is this side all the way over here. So opposite from this angle means if you draw a line, it's all the way over here. That's the opposite side. So that's got a length of 8. How long is the hypotenuse? So that's this piece over here. So we have O and H. So let's think about SOHCAHTOA. That is the mnemonic to remember all of your basic sine, cosine, tangent ratios. So SOHCAHTOA, SOHCAHTOA. And that means sine is opposite divided by hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. A little way to remember sine, cosine, and tangent. Okay, so in a problem like this, I see O and H is what was given, opposite and hypotenuse. So I notice there's O and H with sine. So I'm going to choose the sine ratio. So I can say the sine of our angle, which is 17 degrees, equals the opposite divided by hypotenuse. So 8 divided by the hypotenuse, let's just call it letter X, like in algebra. Okay. So we're going to go ahead in our calculators, make sure it's in degree mode, and say sine of 17 degrees is 0.292371704. It actually just keeps going for a long time, basically forever, right? Irrational numbers. So we're going to cut it off at 4 decimal places, but you always look at the 5th number, and if it's 5 or bigger, you make the 4th number 1 larger. If it's 4 or smaller, you just kind of keep the number where it's at. So I noticed it's a 7, so that means we round up, so it's going to be a 4. So 2924. All of these sine functions, so sine of any number, cosine of any number, tangent of any number, is going to just equal something. Okay, it's just a number. 8 divided by x. So using some algebra, I can multiply both sides by x. Okay, and then what that equals is 0.2924 times x, put the x at the end, equals to 8. We're now going to divide by 0.2924, 0.2924, and what we get is x is equal to whatever that is. So that's 8 divided by 0.2924, and we get that number there, 27.359. Now, when you do your sine, cosine, tangent, it's always recommended to do at least 4 numbers. That's what we just did, 4 numbers. But when you're making a side length, it's recommended to do 1 decimal place. But here it says round to at least 3 decimal places. So we're going to do 3 decimal places for this, which says 359. But the 4th number is a 7. So we're going to round that up to a 3510. So that means it's 360. So 27.360. So when you do something like a 0 at the end, like this, that tells the reader, right? When you write this stuff out, you're just communicating to somebody, myself or whoever, like imaginary person, that we rounded this either down or up, but there's more numbers to go after this. So that's why we put the 0 there. Okay, the 0 does not change the number to 0.36 or 0.36 and 0.360 are actually the same like decimal, but we write the 0 to show that it was rounded to 3 decimal places. Okay. So let's see what we get when we type this in. Did we mess up our rounding anywhere? And this says we're good. Now this says 0.362. So what they probably did was for the 8 divided by that, they probably divided by just sine of 17. They probably didn't round in the middle. So you see how that's better. But they gave us the answer right because we rounded to 4 decimal places and then we're close enough, as they say. Okay, it's pretty cool. They were nice to us. Okay, any questions right now before we move on to the next question? Okay, so make sure you draw your picture out, label it appropriately, okay, and notice what they gave you, look for what you're trying to find, identify like O and H for opposite and hypotenuse, and then look at the SOHCAHTOA little mnemonic, the thing to remember, sine, cosine, tangent, okay, and look for which ones have what you're looking for. It's either going to have OH, AH, or OA, and that will be your right sine function to use. Okay, no questions. Let's go to the next question. This one now looks really complex. They're just making you do like everything. So it's going to be like this, like question 3. It's just going to be all the stuff instead of just a few of the things. So here's question 4. They don't give you a picture, but this problem refers to a right triangle ABC with C equal to 90 degrees. So of course it's a right triangle. C is equal to 90. Solve for all the missing parts using the given information and write your angles in decimal degrees. Round everything to the nearest whole number. All right, write your angles in decimal degrees. I think they mean that as there's other ways to write degrees. There's ways to write degrees with what's called minutes, but we're not going to do that. Minutes and seconds. We're not going to do that though. All right, so we have a right triangle. Let's draw the same picture. I'll make it a little bit bigger to make it maybe easier to read. We've got a right triangle. Doesn't really matter the orientation, but we're just going to draw this to keep it consistent. And it says A is 53 degrees. This is going to be angle C because that's the 90-degree angle, and this will be angle B up in the corner. So they gave us that, and they said, oh, C is 15 feet. So don't forget, across from A is little a, across from B is little b, and across from C is little c. So it says little c, which is the side length C, is 15 feet. So make sure, well, I see here they already gave us the feet there for the side length. So we already know this one. That's cool. And we already know A. That's cool. So not too tough. We already got 2 out of 5. Okay, right there is, you know, what's that? 2, 4, 5, 2 out of 5 is 40%. So at least if you do that, you got 40%. Okay, and how do we find this angle right here? That's angle A. What about angle B? And I would start there. To me, that's kind of the easiest. Every triangle has 3 sides, 3 angles. All 3 angles always add to 180. So I can go ahead, I can say A plus B plus C equals to 180. So angle A is 53 degrees. Angle B, I don't know what that is. I'll just call it plus at angle B. Plus angle C, which is 90, adds up to 180. So a few ways you can solve this. I like to combine my like terms and say 90 plus 53 is 143. Plus angle B still equals to 180. Okay. So now I am going to subtract this 143 to both sides. at any point, you can always use a calculator or even one of those algebra solvers if you struggle with these kind of steps, okay? Angle B will now equal whatever 180 minus 143 is, and that'll be our angle B. Okay, so 180 minus 143 will be 37 degrees. Okay, whoops, angle B. So that will be 47. Oh, 37. What did I put 47? Made a little small mistake. That's okay. Fix that. All right. So this will be 37. Look, we're almost done. We only got 2 sides to solve. Okay. So, and it says here, make sure everything's rounded to the nearest whole number. So we haven't had to do any rounding yet. We probably will for A and B. So we got to solve for A. We got to solve for B. Which one do? You can do either one. I'm going to suggest right now, alphabetical order, you can solve for A. Okay. So let's just go ahead. Let's think of A, angle A, which is 53. Let's solve for little a, which is the side length of A, which is the opposite, and C, which is our hypotenuse, is the hypotenuse. So what do we have? We have our angle, we have opposite, and we have hypotenuse. Okay, whenever you do something like this, I don't want to do angle A and side B right now, because I don't know A, I don't know B, and when you're trying to solve, you only want to solve for one thing at a time. If you try to solve for 2 things, it's just you're gonna end up with your letters gonna move around, but you're not gonna ever solve anything. Okay. So what you have to do is look at just one thing you're trying to solve for. So let's solve for A. So we know the angle, other side, missing this side. We have opposite, we have a hypotenuse. So just like the first one, where we did the angle opposite hypotenuse, that's going to be use the sine function. So the sine of 53 is equal to opposite over hypotenuse, which is A, over 15 feet. We'll just call 15 for now, but we know it's 15 feet. I'm going to multiply both sides, but well, actually, no, let's go ahead and take that sine of 53 and say equals, okay, sine of 53 equals to that. Let's do 4 decimal places. So 0.7986, it rounds down, is equal to A divided by 15, multiply both sides by the 15. And I get 15 times 0.7986. And I get a syntax error. What did I type wrong? 15 times 0.7986. I must have pushed the wrong button. 11.979. That's very close to 12. In fact, that rounds to 12. So we're going to go ahead and call this 11. Well, we'll call it 12. Okay, just because that's what it rounded to. So A is equal to 12. We're almost done. Okay. Now this, I'm going to put a little squiggle, double squiggle. That means about 12. It's like an equal sign, but making wavy lines. Now, because I rounded this, it's very common. It's very, you can use Pythagorean theorem, say A squared plus B squared equals C squared. You could actually do this at this point, but because we rounded this, it's usually recommended to not use this, but to go and keep using our angle and the side that we know. So we're going to use that strategy. That's going to keep things more close and more precise. Okay, so we're not going to, so even though we solved for 37, that was a good angle, that's fine, there's no rounding, but A was rounded, so we're not really going to reuse this to solve other parts of our question. Okay, you rounded, kind of leave it at that. So let's find side B, but this time side B is the adjacent and the hypotenuse is the hypotenuse. So if you remember SOHCAHTOA, which trig function deals with the adjacent and the opposite? And that would be adjacent and opposite. That's the cosine. Okay. So let's get rid of sine. Let's get rid of tangent. We're just going to use the cosine now. The cosine of 53. I wonder what that is. Okay. That's going to equal B divided by 15. So adjacent over hypotenuse. I will multiply both sides by 15. Oh, shoot. After I do the cosine of 53, cosine 53 equal to 0.6018. So we say this is going to be 0.6018. So let's say 15 times 0.6018 And it's about 9.027, so about 9. Okay, is equal to B. All right, that's about 9. Okay, let's see. Let's hit submit. Awesome. Okay, everything looks grand. All right, I'll pause for a moment. Let me put this on the screen. Are there any big questions right now? Okay, at the time. I hear a little beep. What's a little beep? Somebody is saying, no, sir. I'm assuming that means no questions. All right, cool. So let's go ahead and let's jump to the next question then. Okay. I'll be taking pictures of this. Obviously, I'm recording this video right now, so we'll post both these resources sometime after our lesson this morning, okay? So question 5, let me get some more property here. Let me get a new part of my paper. Let's take a look at question number 5 now. It looks pretty much exactly the same, but let's see if it's any different. And I'm looking right now, and it's going to be different. We're going to have to do some cool stuff here. Okay, this is where the fun begins, right? So same thing. I'm going to draw the same triangle. Why not? And then let's read through it. So remember, with any of these shapes, our angles are capitals, our sides are lowercase. Our sides, specifically how you label them, are always opposite to our angle. Okay, angle A, side A, angle B, side B, angle C, side C. Okay, it always kind of goes written like that. So same question, the problem refers to a right triangle ABC with C equal to 90 degrees. So have all the missing parts using the given information and write your angles in decimal degrees. Give all answers to the nearest whole number. So A is going to be equal to 25. B is going to be equal to 19. Now we got to solve for C, A, and B. So we can use Pythagorean theorem to solve for C. So A is equal to 25. B is equal to 19. So we know that those for a fact. But we can do Pythagorean theorem to solve for C. So that would be A squared plus B squared. So 25 squared plus 19 squared. That's going to equal our C squared. So you don't got to worry about doing this stuff in your head. You can just do 25 times 25. That equals 625. 19 times 19 is 361. Now we don't know what C squared is, so we have to combine those. We got to say 625 plus 361. And I get 986. So to finish this off, 986 is not my number, but I have to square root it to get my number. So the square root of C squared is just C. The square root of 986, I have no idea, it equals 31.4, which for the problem, we're just going to estimate it to be 31. This will round down. We'll call this about 31. So we're not going to use this in our problem to solve for the angles because we estimated it. We're only going to use A and B. So I'm kind of keeping that in mind for when we have to do that. So now we have angles A and angle B. How the heck do we find these angles? This is where that inverse sine, inverse cosine, inverse tangent, this is where those functions are going to be used. So let's see how that works out. So you can solve for either one first. It really doesn't matter. My personal preference is to do this. I see A, I see B. Which one do I pick? Alphabetical order says to go to A first. Let's just go to A first. Okay, there's no real rhyme or reason. Everyone's got their own ways to do it. I like alphabetical order. It gives me an option to just pick one. So let's go to A first, okay? So we can say, here's A. From A, this is the opposite. This is the adjacent. This would be the hypotenuse. I told you I didn't want to use C because it was a rounded number. So let's just look at A and B, which are opposite and adjacent. So with SOHCAHTOA, which one is opposite and adjacent? Okay, so sine is opposite hypotenuse. No. Cosine is adjacent hypotenuse. No. Tangent says opposite adjacent. TOA. So opposite adjacent is sides A and B. So we can say, we don't know what the sine of A is. We'll just call it sine of A is equal to A divided by B, opposite over adjacent, which we know to be 25 divided by 19. From here, let's just kind of try to be as exact as possible. So we're going to go ahead and on a step like this, when you have a sign of a variable, okay, capital A is an angle, but really it's a variable in this equation. Okay, depends on what these numbers are, we'll change what this angle is. So how do we do this? It's called the inverse sine. What that does is the inverse sine of sine, it just kind of gets rid of it. It's kind of like adding, subtracting, multiplying, dividing, right? They're opposites. So sine and inverse sine are opposites. They undo each other. And so this just becomes A all by itself. But we're doing an algebra step with our geometry. And so you have to do this to both sides. Okay, that's the rule, right? If you do something to one side in algebra, like square root something, you got to do it to both sides. So the inverse sine now 25 over 19. This is just a calculator thing. And when we finish this, that'll be our final answer. Okay. So calculator time. So in mine, it says sine, and above sine, it says the inverse sine. So I'm going to push so to access these little orange yellow type buttons, we push this orange yellowish button, shift, sine. You see now it has sine to the -1 power. Now mine says 25 divided by 19. So I'm going to put parentheses 25 divided by 19, parentheses to get the most exact number as I can. And now it says math error. Awesome. So I messed up. How did I mess up? I chose sine. Why did I chose sine? I said tangent. That's why we get an error. So we've got to redo this whole thing. We're going to say tangent of A is equal to 25 over 19. So even Mr. Atterbury makes mistakes on this stuff, and this is my favorite type of math to do. I just kind of get so locked into sine. Sine's probably my favorite of all trig functions. You guys are like, what? Atterbury's got a favorite trig function. Yep. So please, pretty please, double check your stuff just like I did here. I messed up. O and A. I even crossed it off. I'm silly. So anyway, same thing applies. Inverse tangent of tangent just becomes A. It kind of like unlocks the angle and gets it by itself. Okay. So this right here is all yuck, Mr. Atterbury messed up. So the inverse tangent of 25 over 19. Inverse tangent, parentheses, 25 divided by 19, parentheses, gives us 57.765. It's 52.8 degrees, but I think they want us to round this to 53. Oops, degrees. Good job. I messed it. So I'm pretty sort of positive A is going to be 53 degrees. So let's type in 53. Now what I'm going to do is I can do kind of the same thing. I'm going to use, since I have two angles now, see I have angle here and angle here. I don't have to keep doing this stuff. I can say this angle plus angle B again adds up to 180 and do that same process again. I kind of like doing that. So I'm going to use this number. I'm going to use 52.8 for this. So I'm going to say angle A is 52.8. That way, in case it says it's wrong, we can go ahead and we can try to adjust from there. So plus angle B plus 90 adds to 180. Let's add those together to get 142.8 plus that unknown angle B adds to 180. Subtract the 142.8 to both sides. Angle B should add up to 37.2. which would round down to 37. Okay, so I'm pretty sure this is going to be 37 degrees up there in that little corner. Let's see if it gives us the answer. Okay, because it's kind of weird. It says write your angles in decimal degrees, give all answers to nearest whole. I think they really just mean decimals, not minutes. I think that's what that is. Okay, cool. They didn't want any decimals there. Okay. All right, so one more time, do a quick recap of this. They just gave us the side lengths A and B. I used Pythagorean theorem to find C. Now it was 31.4 when I rounded to one decimal place, which I rounded down to 31. But when I went and did the incorrectly sign, let's switch back to tangent. So I did the tangent because it was opposite and adjacent. I knew those numbers were like perfect. Okay, those numbers didn't change. Hold on one second because I got a phone call. Let's pause for a moment. Mr. Avery. Hey, what's up? Oh, I'll lock it out in like 1 minute. All right, thanks, man. Sorry about that. Bye-bye. All right. So one last quick review. Okay, we were given A and B. Since we have two side lengths, you can find a third side length by just doing Pythagorean theorem. We did there. Then we had the two side lengths, three side lengths, sorry, now, but we only have one angle, which was 90 degrees. So to find those missing angles, you have to use inverse sine, cosine, or tangent. I chose tangent, even though I messed up at the beginning, but I chose tangent because we knew for a fact O and A, opposite and adjacent, were 25 and 19 to angle A. Okay, that these two pieces, 25 and 19, are opposite and adjacent in reference to angle A. So I said the tangent of A is 25 over 19. Okay, tangent of A is 25 over 19. But to unlock that letter, to unlock that angle measurement, I've got to do the inverse tangent to both sides. So when you do the inverse tangent of tangent, it just becomes A. 25 over 19, because it's algebra type step, you have to do the inverse tangent of 25 over 19. And I went ahead and I just did inverse tangent and I put parentheses to make it as accurate as possible. Okay. 52 rounds up to 52.8, and that rounds up to 53, which you could have done that from the beginning anyways. So, anywho, I'm going to pause right there. I'm going to stop the video right now, so that way you guys can watch this video as you need to.